Hello guys, I am Idishresh Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we were discussing metals and non-metals, and we discussed the reaction of metals with acids, with water, etc. So as you read the concepts or understood the concepts of the reaction of metals with acids as well as water and other reagents, we came to know that all the metals will not react in a same way. Some metals will react in a different way. For example, when you consider water itself, some metals react very vigorously, very violently with the water. Some metals will react very less or less vigorously with the water, like calcium. Some metals will react with the steam form of water, like aluminium. Right. So by this, considering only these reactions, we can't make or we can't write them in a decreasing order of their reactivity. Okay, so we need more information regarding their reactivity so that we can write the elements, that is the reactivity of metals, in the decreasing order. So for that, we should take the help of one of the reaction which we studied in our first concept, that is nothing but displacement reaction. Okay, so using this reaction, by the consideration or by studying this reaction, they have framed reactivity series. Reactivity series. So this reactivity series is framed by experimentally means by proving experimentally they designed this reactivity series. So let us see some examples of reactivity series. So in the first concept, we saw one experiment where I used copper sulphate solution. In that we had dipped iron in. So in that you observed that the copper from the solution has been deposited on the iron nail, and that iron, iron nail which is made up of iron which is present, so that was mixed with the copper sulphate solution, where solution turned to green color. That reaction we are going to write today. So the first reaction is copper sulphate reaction. How do metals react with metal salts? We are going to learn today. Metals react with metal salt. So by these reaction, that is nothing but the displacement reaction, using which we are framing the reactivity series. So copper sulphate solution, when iron nail is dipped in a copper sulphate solution, we got ferrous sulphate and copper. Similarly, when zinc granules are dipped in a copper sulphate solution, we got zinc sulphate plus copper. Then when in a copper chloride solution, when lead had been put, so we got lead chloride along with the copper. Okay, lead chloride. Then when magnesium had been put in a copper oxide solution, so we got magnesium oxide with copper. Fine. Similarly, when in the iron oxide solution, when we dip aluminium, we got aluminium oxide along with Fe. Okay, so when you observe these reactions, so here you can see that in some of the solutions, like in copper sulphate solution, the copper has been displaced by iron. Same way, in a copper sulphate solution where we had been put zinc, the zinc displaced copper. Okay. Same way, when lead is inserted or had been put in a copper chloride solution, lead has been displaced copper from its solution. Mg from copper oxide, aluminium from aluminium in ferric oxide solution. So here, which metal displaces the other metal from its solution? that metal will be more reactive than it. For example, here iron is displacing, iron is taking the place of copper from its solution, means here we can say that iron is stronger. Okay, so here iron is more reactive, we can say. Similarly, in a zinc copper sulphate solution, in a copper sulphate solution where we had been put zinc, so here zinc is taking place of copper in its solution, means zinc is more reactive than copper. Then here lead is more reactive than copper. Here magnesium is more reactive than copper. Same way, in a ferric oxide solution, aluminium is taking place of iron. So here aluminium is more reactive than copper. So using or with the help of this experiment, it was very easy. It became very easy to frame the reactivity series of the metals. What is reactivity series? It is nothing but a list of the metals where we are writing their reactivity in the decreasing order. It is the list of decreasing order of reactivity of the metals. As you can see in the list, see here, copper, iron displaced copper. Iron is here, right? Iron is here. Then copper is down to it. Copper is below iron. Which is below, it is less reactive. Which is above, it is more reactive. So when you compare iron and copper, iron is above. So this is most reactive than copper. Same way, magnesium from copper oxide. See here, magnesium is above, copper is below. Then the most reactive is magnesium. Then we have zinc. Zinc is here, copper is below, so zinc is more reactive than the copper. Then lead. Yes, lead is above, copper is below, lead is more reactive than copper. Similarly, aluminium. Aluminium is here, iron is here. Aluminium is here, iron is here. So, when you compare, aluminium is above the iron. So, aluminium is more reactive than iron. So, this is regarding the reactivity series. So, in the reactivity series, the metals are listed based on their decreasing order of their reactivity. So, here potassium is most reactive and silver is least reactive. Potassium is most reactive and silver is least reactive. So, based on displacement reaction, the reactivity series has been framed accurately, we can say. Right? So, this is about the reactivity series. In the next concept, we are going to learn. First, we learned how metals react with the water, with the oxygen, with acids, and also with the salts of their metals. Now, we are going to learn how metals react with the non-metals. What is formed? What is the structure in it, or what is the mechanism or process in it? What is that bond is called? So that all we are going to learn next. Okay. So let me rub this. So today we are going to learn regarding how metals and non-metals react. For this, we should know certain concepts, or we should recall certain concepts of 9th standard, guys. So in 9th standard, you learned regarding the electronic configuration, right? It is nothing but writing the electrons, number of electrons of an element. And we know that we also learned regarding the concept of noble gases. Noble gases, right? So what are noble gases? So these are nothing but, these are very stable and these have octet electronic configuration. Octet electronic configuration. What is octet electronic configuration? That is, last shell of an element or of an atom, last shell, what we can call it as KLMN, whichever will be the last shell. So that last shell should be completely filled with the electron. This last shell should be completely filled, or octet configuration it should have, we will see. So all the elements in the periodic table always want to get this octet electronic configuration, that is completely filled electronic configuration, so that they will become stable. Stable andre they will become less reactive anta. They will become less reactive. So we can say all the elements will be striving to get this octet electronic configuration. All the elements will be trying to get this octet electronic configuration. Right. So let us consider here. Let me consider sodium. Okay. So we know that its symbol is Na. Its atomic number of electrons or number of proton, okay, it is nothing but 11. So how we will write electronic configuration of it? So KLM, in K 2 electrons will be filled maximum. In L can take 8 electrons, 8 plus 2 10, M can take 1. We know M can take 2 3 square 9, 18 electrons, but we need only 1 electron. 8 plus 2 10 electrons are there. So 11 as the atomic number. So here it says that number of protons is equal to 11, as well as number of electrons is equal to 11. But sodium is not stable. Why? Because it does not have octet electronic or completely filled shell configuration. So here, if this electron has been removed from M, so what happens? Then the electronic configuration of sodium becomes 2 8. So last is 8. Last shell will become L. First last shell was M. Now last shell is L. How many electrons L has? 8. That is nothing but octet electronic configuration. Last shell should have maximum 8 electrons. Then the element will become stable. So 8. So what happens now? When sodium loses 1 electron, it will attain octet electronic configuration. So here, let us think. Now sodium is losing 1 electron. Sodium 282 is there. So it does not need the electron. So it is losing 1 electron. So when it loses 1 electron, the number of electrons, what we can say, it becomes 10. The number of negatively charged particle becomes 10. Whereas the number of protons remains 11 only. So as we can say that number of positive particles are more, number of negative particles are less. That is why Na attains the positive charge. Okay, Na, that is sodium, attains positive charge. So here we can call this as Na plus. So it is called sodium cation. Why cation? It got a positive charge as protons are 11. It lost 1 electron. Similarly, let us take chlorine. So the symbol is Cl, the atomic number is 17. So if I want to write the electronic configuration, 2, 8 is 10 and 7 is M. So the last shell is M. It has 7 electrons in it. Now you can think that if the chlorine has to get octet electronic configuration, octet andre 8 electrons should be there in a last shell, that you remember. 8 electrons should be there in a last shell. So here, if the chlorine wants 8 electron in its last shell, it can do 2 ways. One is it can lose all the 7 electrons. Okay. Otherwise, it can get to 1 electron. ಎರಡು ವೇ ಇದೆ ಇದರಲ್ಲಿ. ದಟ್ ಈಸ್ ಇಟ್ ಕ್ಯಾನ್ ಲೂಸ್ ಆಲ್ ದ 7 electron or it can get 1 electron. So we know sodium is a metal, I forgot to say, and chlorine is a non-metal. But think, instead of losing all the 7 electrons, it is very easy to take 1 electron. Okay, losing all the 7 electron is not so fair idea. So it is very easy to get 1 electron. Now we can think that sodium wants 1 electron. Sodium don't want 1 electron. Chlorine needs 1 electron. So here chlorine 287. So it wants 1 electron. Now, so as number of electron, ಇಲ್ಲಿ chlorine ಅಲ್ಲಿ ಏನಾಗಿದೆ 17 ಅಂದ್ರೆ number of proton is equal to 17, number of electron is equal to 17. So what happens? It want one more electron plus 1. Means number of negative particles increases when it got one more electron. One electron add ಆಗ್ತಿದೆ ಅಂದ್ರೆ one negative charge add ಆಗ್ತಿದೆ ಅಂತ. That is why it becomes negative. So this we can call chloride anion. Negative charge anion, positive charge cation. Now here what happens? Na want to lose 1 electron. Sodium wants to gain 1 electron. So some friendship happens between two. Because as give and take relation occurs in between two. Let us see that. Na plus, okay, plus Cl minus. Let us see. Na, it want to lose 1 electron, right? Then chlorine. So we should write the last shell here. The last shell alli 1 electron ide. So 1 electron. The last shell alli 7 electrons ಇದೆ. So 7 electrons I should mark. 1, 2, 3, 4, 5, 6. Label or mark the electron in a different shape. Okay. Now what happens is NaA will give 1 electron to this, to chlorine. Na will give 1 electron to chlorine. So what happens there? Na will lose electron, Cl will get 1 electron. Loses 1 electron, sodium got positive charge. Okay, as it gains 1 electron, chlorine got negative charge. So both are opposite. These both opposite charges will attract to one another. Means electrostatic force will be developed with one another, which makes them NaCl. This electrostatic force leads to the formation of a compound which is called ionic compound. It will be not a molecule, it is an aggregation. Adu molecule iralla, it is aggregation of oppositely charged particle, group of oppositely charged particle, which is called ionic compound. Why we call ionic means charge are called as ions, and these charges, oppositely charged particles, are held by an electrostatic force which is called ionic bond. So electrostatic force, it is nothing but force between the charges. It is nothing but force between ions. Okay, force between ions. So that force is called as ionic bond. So ionic bond is present in the ionic compounds. That is bond between positive cation and the anion. Okay, how it occurs? Some metals want to lose electrons, non-metals want to gain electron. So this give and take relation forms bond two of them, which is called ionic bond. Such compounds are called ionic compounds. Okay. So let us take one more example here. Let us take one more example. Okay, let me take magnesium. Magnesium, okay. So the symbol of magnesium is Mg and its atomic number is 12. So its electronic configuration is 282. Similarly, Cl, that is chlorine, we will take. Okay, Cl is 17, atomic number is Klm, so 287. Fine. So here, as magnesium has 12 electrons and 12 protons. So protons is 12, electrons are 12. Here protons are 17, electrons are 17. Okay. So here, to want stable octet configuration, magnesium want to lose loss of 2 electrons. So loss of 2 electron make magnesium to get octet electronic configuration. So we can write as magnesium want to lose 2 electron plus 2 electron. Okay, 2 electron. So as it loses 2 electron, but it becomes 10, right? 2 electron andre, yeah. 2 electron means it becomes 10. 8 plus 2, 10. But the positive charges remain 12 only. That is why we can write 2 plus here. 2 electrons, 2 plus. Similarly, chlorine want to get 1 electron. So it want to get 1 electron means Cl plus 1 electron gives Cl minus. Again, Cl plus 1 electron gives Cl minus. You will understand why I wrote twice. Now, magnesium don't want 2 electrons, chlorine want 1 electron. But if 1 electron is given to the chlorine, magnesium will be having 1 more electron to give. Where it has to give? That is why magnesium says to chlorine, you give me 2 atoms. 2 atoms of chlorine. So that 1 electron I will give to 1 chlorine. Other electron I will give to other chlorine. So what happens here actually? The dot structure. Magnesium. So how many electron it has? Outer it has 2 electrons. Right? So let me write it differently so that the transfer I will show it in a better way. Next, chlorine. 1 chlorine has 7 electrons. Okay. As magnesium has 1 more electron to give. So chlorine, 1 more atom of chlorine we will consider which has 7 electrons. Right. Then, so this magnesium gives 1 electron. This magnesium gives 1 electron to this chlorine atom and other electron to this chlorine atom. So what is formed? The electrostatic force has been developed in between 2 atoms, as these are both oppositely charged particles. So here Mg 2 plus, as it loses 2 electrons, and Cl we will get with 2 electrons of Cl2 na, because Cl2. So 2 electrons which we got from the magnesium. Instead of writing separately, I wrote 2, Cl2. Okay, MgCl2. So MgCl2 is also the example for ionic compound. So in exam you will get the question like write the dot structure or write the formation of magnesium chloride. Write the formation of sodium chloride. Then you have to write this reaction, this and this. Dot structure is very important. And remember, these are not called as molecules. These are not called as molecules. These are the aggregation of oppositely charged particles which are called ionic compounds. So this is regarding the formation of ionic bond and the definition of ionic compounds. In the upcoming session, we are going to deal with the properties of ionic compounds. Until that, take care. Have a nice day. Bye-bye.